I'm Jonathan, and this is Math Learning, a place to learn freely without ads or noise. Let's continue our journey. In this video, we start our journey with learning IPv4 subnetting. This is part one of a multi-part series, and I do not yet know how long the series will be. But this video should be a bit shorter than the other ones that I have made. In this video, I will cover CIDR notation, what they call borrowing bits, and ANDing. If that sounds redundant, that's exactly right. Now, at this point, if you have not watched my video on IPv4 addressing, I strongly recommend you do that. And if you look at these QR codes, the one on the left is for the video post on my Substack, and the video and the QR code on the right is the uh, link to the YouTube video, and the links are also written below if you want to type that in your address bar. But if you have watched this video, please continue. It will make a lot more sense if you have watched the previous video. So this is the slide where I left off in the IPv4 video with the CIDR notation. And I said at the end of that video that when I talked about subnetting, I would describe exactly what CIDR means. And that is what I'm going to do now. Every word in the CIDR notation means something specific. The C stands for classless. And what that means is we are breaking down the default subnet masks to create more networks at the cost of less hosts per subnet. So you remember before when I talked about a Class A network having 16 million hosts per network. This chops that up into a lot more networks, but you're going to have less hosts per subnet when you do that. The I is the prefix inter, and when you think of inter, the opposite is intra. So if we have an intranet, that is a network that is within a company. Internet is the global internet at large, but it just means other networks that talk to each other. So when we say inter, it means from one to another that is external from ourselves. The D stands for domain, and that means each subnet is considered its own domain, where domain means everything within that domain can talk to each other with basic networking equipment. It doesn't need anything advanced. And then finally, the R stands for routing. And this doesn't necessarily mean the network equipment router. It just means routing as a verb, which is the act of carrying traffic from one network to another. So when we take the entire acronym CIDR and we put it together, it means the act of creating more smaller networks from a large network for the purpose of mass communication through use of a device that can relay the traffic from one subnet to another. That's a very long definition, and I did make it up myself off the top of my head based on what each of these definitions mean, but that's literally what it does. Um, it creates small networks that can talk to each other with a routing device. And like I said, it doesn't have to be a router. It could also be a computer acting as a router, or a virtual network with a virtual router, so on and so forth. Now, this is where subnetting begins. When we subnet, when we take a larger network and we break it into smaller parts, Back in the day, we used to call this borrowing bits. Now, it's called borrowing because really, stealing connotates that it's bad. But borrowing sounds better. But really, what we're doing is we're taking more bits from the host bits and using them for the network. And if you remember from the IPv4 video, I used this example IP address of 192.168.1.15/24. And that is a default Class C notation. So here is an example, a very basic example of subnetting. If you remember from the previous video, if we have a default Class C network, then we have one network with a possibility of 254 addresses in that one network. Now, yeah, there's a lot more networks available, but we're talking about one specific network. So we have a single network, the 1.0, which means all the bits, all 8 bits in the last octet are used for the host. Now, when we borrow bits from the host, what it looks like is the network address right below it. Here, 192.168.1.0/25. So instead of 24, we are taking one more bit from the host and turning it on, because when you subnet from the left to the right. And that is true whether we're using a default Class C, Class A, Class B, or we're subnetting. It always starts from the left and keeps going to the right. And in this new example, borrowing one bit from the host octet creates 2 networks. It divides it in half. We're not going to get into exactly how that happens yet. That will come later. But when we write all of these down in binary, it makes more sense. So this top binary number is the default subnet mask. Okay, so we know if every bit is turned on in an octet, that means that the decimal number is 255. Okay, so 256 total values with 0 being a number. So it's going to be 255.255.255.0. That is the default subnet mask. Now, when we take the new subnet mask, it's the same thing, but you can see this red bit here is being borrowed from the host. We can't have more binary bits than 32. We have to make use with what we have. So that's why they call it borrowing bits. And if you remember from the binary scale of the power of 2 in my previous video, you know that this leftmost bit in the octet is 128. So this new subnet mask is going to be 255.255.255.128. Okay, that's the new subnet mask. And then this bottom number in binary is the IP address of 192.168.1.0. You can go ahead and do the math, but that's how it works out. And no, I did not do it in my head. I went to a subnet calculator online and fed it each number, and this is what it gave me. Sometimes I cheat. Not on exams, but when I need to come up with numbers quickly, calculators help. So why does this help us? Because we don't think in binary. Well, to understand subnetting and subnetting architecture and traffic, we need to understand how routers look at these addresses, and this is exactly what it does. Routers, when they are doing their routing functionality, don't care about IP addresses. They only care about networks, and this is how it does it. If we break it down even further, this goes way back in the days of people teaching subnetting. If you have learned subnetting before, you may have heard of anding. And if you have heard of it, it is probably the biggest nightmare that you have heard of when it comes to subnetting, because it is just a horrific way of teaching subnetting. But this is how routers understand it. And we have to understand what anding means if you don't know what binary math looks like. So this is what binary math looks like in a logical way. And that's actually what it's called, logical operations. We have and, or, and what's called XOR, or exclusive OR. Now, exclusive OR is used mainly in programming, but it's also used in hacking and anti-hacking efforts, and that will be in a completely different lesson. But the way that anding works is the other word for anding is multiplying, because if you do regular math, anding is also known as multiplication, which is also known as getting the product. So 0 and 0 is 0 times 0, which equals 0. 0 and 1 is the same as 1 and 0, which also equals 0. And the only way you get a 1 is if you have 1 and 1. You can also think of it as true and false. And means that both have to be true in order for the end result to be true. With an or, either one or the other or both have to be true or on for it to be a 1. So 0 or 0 ends up being 0. 0 or 1 ends up being 1. And 1 or 1 ends up being 1. And then finally, the exclusive or. What this means is one or the other has to be a 1, but they can't both be the same at the same time. Okay, so 0 XOR 0 and 1 XOR 1 both equal 0. Only 0 or 1 put together equals 1. And if you're listening on a podcast, I apologize. It makes more sense when you're looking at this on the screen. So if you're listening on a podcast, I do recommend later on going to the Substack or YouTube clip of this so it'll make more sense. Now, I pose this question for you viewers. If I have an IP address of 150.120.130.50/28. Okay, /28. So we are borrowing bits into the host network, and in this specific, or the host bits, and in this specific example, we're borrowing 4 bits. 24 plus 4 is 28. Now I pose this question. If a device that has an IP address of 150.120.130.55 with this subnet mask, okay, it's going to be 255.255.255. Question mark, but it ends up being the /28. If it wants to talk to another device that has the same first 3 octets, but the last octet is 65, would they be on the same network? Would they be able to communicate with each other without an intermediary routing device? Well, when a router has to make this decision, it does what's called anding. So what it does is it takes each IP address and it ANDs those bits with the subnet mask, the new subnet mask, and it compares the two IP addresses. And if the resulting binary bits match, then they're on the same network. If they don't match, then they're on a different network. And that is literally what a router does every day. So what we do here is on the top, I have the .55 address written in binary here. The middle binary is the 65, and the bottom is the subnet mask. Now, what the actual subnet mask, if you do know, awesome. I didn't bother because it's not really important at this point. That will come later. But if we look at where the bits end for the subnet mask, okay, it ends right here where the ones end in the subnet mask and the rest of the 4 bits are zeros. So these last 4 bits in every address here don't matter. We just don't care. Okay. We're only looking at where the bits are ones as far as the subnet mask goes. The subnetted, the new subnet mask. Okay. Now, the fact that these two addresses have both zeros in the leftmost bit is not important. Okay. It doesn't mean that they're not in the same network. It means that the numbers are the same. So what we're going to do is we're going to look at every single digit, binary digit, from the left to the right and see where they differ, okay, in both IP addresses. So you can see because all of the first 3 octets for 150.120.130 are the same in both addresses, we don't have to care about the first 3 octets, the first 24 bits. Okay, they're the same, so we know so far it looks like they may be on the same network. However, if we go 1 bit to the right, we have 0 and 0, meaning they are the same. But the first bit here on the top address on the 55, it's a 0. Whereas on the second IP address of 65, it's a 1. And the reason why is because the first binary bit is the 128, and the second binary bit is 64. To make 65, we take 64 plus 1. Okay? With a 55, it's 110111. And all of those added together equal 55. But the difference is this binary bit right here, the second to the left. And because those 2 bits are different, they are on different networks. Okay. So that means they cannot communicate with each other by default. If you were to put these 2 devices configured with these IP addresses on the same network and the same subnet mask, they would have no idea how to talk to each other. Now, that was subnetting part 1. Complicated? Yes, very. But I promise the, the next video is where it'll all make sense. And that is how it worked for all my previous students. They were completely lost up to this point, which is perfectly fine. We just have to remember way back in the days of regular math, specifically like long division. If you were really good at math, you could do long division in your head very quickly. But they always said, I want to see your work. I want to know that you know how to do it the really long way. So you would do long division in the super long way. And then if you did it right, a bunch of different times, then the teacher would say, okay, fine, I'll let you do it in your head. Okay, this is the same thing. I want you to be able to do it the long way before you can do it the very quick way. And starting the next video, part 2, we will learn the quick way, and this will all make sense. So what will I cover in the next video? Well, I am going to go over the subnet mask table, which will help you memorize the subnet masks. Remember when I said the 4 bits that are borrowed into the host, I don't remember offhand what the bits are. Well, this will teach you how to do that. The magic number, it is exactly what you think it is. It is magic, and I will explain it in that video. And we'll go through some practice exercises, and I will show you just how quickly you can do this. Thanks for being here. If this helped you, share it with someone who's learning too. Everything I make is free, and if you want to support the mission, the links are below. I'll see you in the next one.